Oh, hey, didn't really see you there. So, today we're making ice cream and caramel, homemade. What we're gonna have to start with right now is 1 cup of sugar, 6 tablespoons of butter, but we actually are using 4, and 1/2 cup of heavy whipping cream.
Hey, didn't see you there. We are making caramel sauce. At the start, you're gonna melt the sugar until it gets to a dark amber brown color. This is gonna take a long time, but make sure you use a copper or a thick bottom pan to distribute the heat evenly. And you want the pan to be tall enough so that when you add the other things, it doesn't boil. Wooden spoons do not melt like plastic spoons would. The plastic spoons are not good to use for this.
Hi, my name is Brad Chesney, and for our project we decided to do caramel sauce and ice cream. The topic I'll be discussing today is conduction, radiation, and convection. Conduction is the transfer of heat from one substance to another through direct contact. Radiation is the transfer of energy by waves through the air. And convection is the movement of molecules within fluids. So you may be asking, how does this apply to making ice cream and caramel sauce? For ice cream, conduction is used with the heat passing through the ingredients, through the bag, to the ice. For caramel sauce, conduction is used when you touch the heated pot. Radiation is used through the waves of heat through the air. And convection is used through the movement of molecules in the caramel sauce in the pot. So as shown on this diagram here, convection is in the ingredients in here and is being transferred around, while conduction is, as shown here, is being transferred through the heat in the pot. And radiation, as these squiggly lines show, is the air waves of heat. Alright.
My chemistry concept is the structure of the caramel sauce. Alright, so one of the really interesting things about caramel sauce that scientists didn't really realize actually until a few years ago, in 2007, they discovered that sugar actually does not melt. It decomposes. It seems like it's melting, but what it's really doing is it's changing its chemical composition from sucrose into fructose and glucose. This happens at approximately 160 degrees Celsius. And it can also happen between 140 and 160 degrees Celsius, depending on factors such as how fast you heat it. Scientists call this apparent melting. This is because sugar seems like it's melting, but it is really decomposing. Because the reason that it took a long time for scientists to realize that sugar didn't actually melt was because they blamed it on impurities and instrumentation differences. It is hard to distinguish the thermodynamic melting, like the melting or freezing of water in the ice cream, and the decomposition of sugar, aka apparent melting. This diagram here shows how sucrose breaks down into glucose and fructose. Then it goes through a complex chemical reaction that can go into multiple different ways, depending on variations in the temperature, prevalence of water, and other things that scientists aren't even sure about. This complex reaction isn't known very well and is still being investigated by scientists. Alright, well shoot. I burned it. My fault.
Time for ice cream time. Add as much ice as possible to our handy ice cream dish. Now we're going to add 8 tablespoons of rock salt.
Now add our mixture. So here we have 1 pint of cream, 1.5 teaspoons of pure vanilla, and 1/3 cup and 2 tablespoons of sugar.
Perfect.
You have to do this for about 20 minutes.
Now, let me explain the chemistry behind this nifty device here. So, in this cylinder here of metal, we have our cream, of course, which we saw. What the ice does around it is it's going to create ice cream. Now let's talk about freezing point depression. What happens is, with the ice, we add the salt to the ice, and the salt interferes with the crystal formation in the ice, thus causing the freezing temperature of the ice to go down, and the ice to melt, even though it's getting colder. This is known as freezing point depression. During this phase change, the ice is absorbing the heat from the liquid ice cream, causing this solution to decrease in temperature, making ice cream.
Now that is some good ice cream.